Okay, hello everyone. This is Jessioverse Academy, and here with you is Jessio Precious. So today we have little quizzes that would want to show you so that you could learn with us. So firstly, it's on physics. So here we have a transformer with 5,500 turns in its primary coil or wounding is used between a 240 volt AC supply. In other words, the input voltage is 240 volts and a kettle of 120 volts. That means the output voltage is 120. Definitely is a step down transformer. So calculate the number of turns in the secondary coil. So now the thing is this: you must have seen transformer one way or the other. The essence of a transformer is to transmit voltage through a long distance at a very low cost. So it's the types of transformer because that's a very good head start. We have the step down transformer or step up transformer firstly, which means that the output voltage is greater than the input voltage. We have the step down transformer as the name entails, which means that the output voltage is less than the input voltage. We also have the isolation transformer where the number of the quantity of the output voltage is equal to the quantity of the input voltage. And here we also want to talk about the transformer ratio, which is the formula for whatever problem we have at hand. So here we can see very much at the foot of this board that the input voltage, the ratio of the input voltage to the secondary, or you say the output voltage, is a constant. The same thing goes for the ratio of the number of turns in the primary coil of a transformer to its number of turns in the secondary coil is also equal to a constant. And since that is said, we are going to use that. On the other extreme end, we have for current, which means the current on the secondary coil is, okay, this is an inverse proportion here now. The current in the secondary coil is to its primary coil is also a constant, blah, blah, blah. You can see that for yourself on the board. So now let's use this idea now to solve this problem. So a quick one, solution. So we have voltage in the primary coil, voltage in the secondary coil is equal to the number of turns in the primary coil over the number of turns in the secondary coil. And with that light, we believe that the voltage in the primary coil, which is the input voltage, is 240 volts all over. The output voltage is 120 volts, equal to the number of turns in the primary coil is about 5,500 turns all over. Let's say that the number of turns in the secondary coil is um, X. Bear it in mind that this is a step down transformer whereby the the output voltage is less than the input voltage. So let's cross multiply in order to convert this to a linear expression. So we have here 240x is equal to 120 times 5,500. So if you were to check that out in a calculator, you will find out that, okay, let's see our calculator. I want to do this every step of the way with you. Now that we have 660,000. Now that we have 660,000, we might want to get back to our board. Okay, so we have 660,000 is equal to 240x. In order to find out the value of x, you'll be dividing through by 240, pardon. So 240. So 240 gets to cancel 240, leaving you with just x, and x is equal to 660,000 divided by 240 will definitely give you an answer in the options. So that would be divided by 214, which is equal to 2750. So we've obtained clearly what we want, and let's see if the options are available. Okay, so yeah, the options is the B, and there we go. We solved the problem in one of the external exams. So provided you have confusion or you still don't get how this came to be, I am always here for virtual classes with my students, and we do a lot of didactic learning and improvement. So thanks for watching. I'm very grateful.
Hey, or maybe you could try a simpler version of what I just did. Check in the next slide.